2.2c is on expressions and equations. So, remember that an equation is a mathematical statement that shows one expression is equal to another expression. When the expression on one side of the equation equals the expression on the other side, we say the equation is balanced. So the whole point of an equation is for them to be equal. It is literally a part of the word. Equations mean they are equal. Okay? Right, so when we're looking at it, when we're trying to find a value or trying to balance something, that's always our goal. In order for an equation to be true, in order for it to make sense, one side has to be equal or represent the same thing as the other. Again, that's the whole idea behind an equation. So, an expression, remember, like 3 times the quantity of 4 times 2. That's an expression. 6 minus 2. That's an expression. When you put them together with the equal sign, that makes it an equation. So, example 2. These expressions form an equation. There's only one value of n or c that will balance this equation. So we're trying to figure out the value or the number that would make both sides of this equation equal or balanced. So if we have the expression n plus 25 equals 30, well, we just want to figure out what plus 25 is 30. Well, 5 plus 25 is 30, which tells us that in order to balance this, n would be 5. The second one, we have an expression 52 is equal to the expression 4 times c. So we're just trying to figure out 4 times what would be 52. Another way we could think about it is 52 divided by 4 is what? Either way, the answer is 13. So we're saying 52 is equal to 4 times 13, which would give us 52 equals 52. They're the same. They're balanced. Each side represents the same thing. So in order for this to be equal or balanced, c would have to be 13. That's the only number or only value c could be. Right? It couldn't be anything else to make that equation true or balanced. Notice we have a lot of vocabulary, but they mean the same thing. Right? If something's equal, it's balanced. That's what makes it true. If both sides are worth the same amount or represent the same amount. So here's another example. The algebraic expression 3x plus 1 equals the algebraic expression x plus 16. Now both sides have a variable and they both have an x. So this needs to be the same number. So 3 times something plus 1 is equal to that same unknown number plus 16. Okay? So these expressions form an equation. There's only one value of x that will balance this equation. There's just one value. We will learn to solve equations for that value in this unit. Okay? So example 4, we can show that expressions are equal by simplifying both sides of the equation. So I'm going to draw a line down here to separate the two sides of my equation. And now I'm just going to simplify them individually. So I'm going to start just by looking at 3 times the quantity of 6 minus 2 squared. Well, remember PEMDAS. Parentheses, exponents, multiply, divide, add, subtract. We want to do our parentheses first. Well, in our parentheses, it's 6 minus 2 squared. So before I can subtract, I have to figure out what 2 squared is. So this would be 3 times 6 minus 4. Well, 6 minus 4 is 2. So this is 3 times 2. 3 times 2 is 6. Now that we have simplified the left side, we want to simplify the right side. Negative 4 plus 18 divided by 2 plus 1. Well, we have to do division first. 18 divided by 2 would be 9. Negative 4 plus 9 plus 1. Now we do our addition from left to right. Negative 4 plus 9 is 5. 5 plus 1 is 6. 6 equals 6. So these are equal. This is true, it's balanced, because we have the same value, 6, on the left and 6 on the right. Let's do a couple more examples. That same idea. We're just trying to show that something is equal, that it's balanced. So again, I'm going to draw my line. I'm going to start with my left. 6 divided by 2 plus 3 times the quantity of 4 minus 3. So I do my parentheses first. 4 minus 3 is 1. So we have 6 divided by 2 plus 3 times 1. Well, do our division and multiplication from left to right. 6 divided by 2 is 3, plus 3 times 1. 3 times 1 is 3, so 3 plus 3 would give us 6. Now we go ahead and we evaluate or simplify the right side. 5 times the quantity of 2 plus 1, excuse me, minus 3 squared. So do our parentheses first. 2 plus 1 would be 3. Then we do our exponent. 3 squared means we have 3 times 3, which is 9. 5 times 3 minus 9. Well, then we multiply. 5 times 3 is 15. 15 minus 9 is 6. 6 is equal to 6. They're the same on both sides. That's how we know they are equal or balanced. That is what makes this true. Let's see. We just have a couple more examples that we're looking at here. So this next one, we actually need to make something up. So when we're looking at it, here we see an expression on one side of our equation. We want to write an equivalent expression on the other side. So we have 7 times the quantity of 5 times 2 minus 20. All right. Well, let's figure out what this is equal to first off. So in our parentheses, 5 times 2 would be 10. So we'd have 7 times 10 minus 20. 7 times 10 is 70, minus 20 is 50. The left side is equal to 50, so we have to make up something. Anything we want on the right-hand side that equals 50. There are no rules. The only rule, okay, there's one rule. You can't just write the number 50, right? We want to be a little more creative than that. So we don't just want to say 50. We want to make something up. We want to make something up that's got an operation, you know, where we have to add, subtract, multiply, or divide, or we could do multiple of those things. Okay, so it can be as creative or boring as you want it to be. We could do an easy one. We could do 49 plus 1. 49 plus 1 is 50. We could do 7 squared plus 1. Right? 7 squared would be 7 times 7, which is 49. What else could we do? We could do 10 plus, let's see, 60 divided by 2 plus 13 minus 3. That would be equal to 50. Let's double check. 60 divided by 2 would be 30. 10 plus 30 plus 13 minus 3. 10 plus 30 is 40. 40 plus 13 is 53. 53 minus 3 is 50. So all of these are examples of expressions that are equivalent to 50. So again, whenever you're building one like this, you can make up whatever you want, just as long as it is equivalent to that other side. Let's do another one. 6 times the quantity of 3 times 7 minus 10. Well, 3 times 7 is 21, so we have 6 times 21 minus 10. 6 times 21 would be 126. Minus 10 would be 116. So again, you can make up whatever you want. You could do, let's see, 116 is 100 plus 16. So I could do 5 squared times 4 plus 20 minus 4. And we could double check that that's actually 116. 5 squared is 25. Times 4 would be 100. 100 plus 20 minus 4 would be 120. Minus 4 is 116. So again, these are both examples of expressions that are equivalent. Okay, so there are many different options when you're making up your own expression. It's important to remember that the expressions on either side of an equation do not have to look the same. However, to be balanced, they need to be equal the same amount when simplified. Okay, there are a couple examples for you to try on your own. Remember, balanced means that they're equal. They're the same value on both